Hi everyone, welcome back again to our YouTube channel, and in this video we will study the applications of Kirchhoff's current law with the help of one example. So let's begin. So this is the circuit given to us, and we need to find out the current Ix. You can see here Ix, Iy, Iy, here Iz, then 3 amperes going towards the vertices and 5 amperes entering at the node at the center of the pentagon. Now what we need to find out is the case 1. We'll try to do 3 cases in this. So in case 1 we need to find out Ix, where Iy is given as 2 amperes and Iz is given as 0 amperes. Okay, now as we know that to apply the KCL we have to find out the nodes. So how many nodes are available in the circuit? If we look as per the definition of the nodes, it says more than 2 branches, the point where more than 2 branches meet is called node. So if you see here, this is one node, this is another node, let's say it A, this is another node B where this and these 3 branches are meeting, this is node C where these 3 branches are meeting, then so D and E. Now there is one more point where like 5 amperes, then this, all these are meeting at this point. Let's name it as node O. Okay, now we need to find out the current Iz while Ix when Iy and Iz are given. So we need to so there are how many possible nodes? Like 1 2 3 4 5 nodes plus 1 at the center, 6 nodes. Now which node should we apply the KCL is should be our the first goal to figure out. Okay, so since we need to find out Ix and given is Iy and Iz, it means we should consider something which contains that the node which contains all these variables Ix, Iy and Iz. So if you look at the node which contains everything, that is the node O, right? So first we need to figure out the node at which we need to apply the KCL. That we found out as node O, because node O contains Ix, Iy, Iz and 2 more currents, which is one is entering and other is leaving the center of the pentagon, right? So let's apply the KCL at node O. If we do so, we get Ix, which is exiting the node. So as per the KCL, what we can say is current entering the node is equal to the current exiting the node. So write down KCL at node O. Okay, so the current entering the nodes are Iy. You can see here Iy is entering the node, Iz is entering the node, and 5 ampere is also entering the node. So these are the currents entering the node. So let's write down Iy plus 5 plus Iz equals current exiting the node, right? So exiting the nodes are Ix and 3 amperes. These are the 2 currents which is leaving the node O. Thereby we can write here Ix plus 3. Now this is the one equation. Let's name it as equation 1. Now the condition given in the case 1 is Iy is 2 amperes and Iz is 0. So this is 0. So let's so Iz is 0, thereby we can write Iy is 2 plus 5 plus 0 equals Ix plus 3. So if you solve this, what will we will get as Ix equals 5 plus 2 7 minus 3 4, right? So 4 amperes of the current. It means so 4 amperes of current is exiting the node O and going towards the node B. Okay, so that's the answer for the first part. So let's look at the another case, another condition. So let's now find out the Iy. Given that Ix equals 2 amperes and Iz equals twice of Iy. Now in either case, since the circuit is same, the diagram is same, thereby the KCL will not change. The nodal equation at the nodes will not change. Therefore, the node, whatever we had written for the last case, will work fine for this case as well. Therefore, the equation remains same. Now in this equation, put these conditions. We need to find out current Iy So let's write down Iy plus 5 plus Iz. Iz is twice of Iy equals Ix, which is 2 amperes given here in the case 2, and that gives us twice of Iy plus Iy, which is 3 times Iy equals 5 minus 5, which is 0 amperes of the current. It means there is no current flowing in the branch containing Iy, right? It means this is a open circuit. So that's the zero current implies the open circuit. It means circuit is open. Now let's look at the another case where all these currents Ix, Iy and Iz are equal, and we need to find out Iz. So we'll have the same KCL at node 0 which we have used in the last two cases. So given that, since it is given that all these currents Ix, Iy and Iz are equal, thereby let's consider for the solution, let us consider Ix equals Iy equals Iz equals I. So I plus 5 plus I equals I plus 3. So I and I gets cancelled. We get I equals 3 minus 5, which is minus 2 amperes. It means which is equal to Ix equals Iy equals Iz. So the negative sign represents the direction which is given in the circuit. The current flows in the direction opposite to the direction given in the circuit. It means what we got, the direction of current in the case 3 changes. Okay. So Ix, Iy and Iz, right now as per the circuit, Ix is exiting, leaving the node O. So it will enter the node O, right? Since it is minus 2. Similarly, Iy will, instead of entering the node, it will exit the node O. And similarly for the Iz, instead of going away from the node D towards node O, it will leave the node O and move towards the node D. That is the significance of the negative sign in the circuit. So that's all about the three cases of KCL. Hope you found this video insightful. Stay connected. We'll look at the another example in the next video. Thank you so much.